2025 is a special year. When you look back at this moment, you will find that the way humans understand the universe is quietly changing. Let's take the time expressed together today. Go see those exciting top 10 cosmic discoveries and breakthroughs with far-reaching impact. This year, the star of the original circle of astronomical circles is 3A Atlas. If you say second, no one feels first. It was discovered by the Asteroid Impact Warning System on July 1st, 2025. It was about 4.5 astronomical units from the Sun at that time. It comes on the heels of 2017's Olympic Games and the violence of 2019. The third confirmed interstellar visitor to the solar system. He will accelerate away from Earth after passing the golden location on the 19th. After passing Jupiter's orbit in March 2026, it will be completely out of the attractive forces of the solar system, returned to interstellar space. Not long after it was discovered in the 3 Atlas, American physicist, Harvard science professor Avaleb thinks he may be the creation of alien life. They might even attack the Earth. But after continuous observation and verification, prove that Sheen Atlas is an ordinary interstellar comet. Discussion on the Cyan Atlas clearly demonstrates the relationship between hypothesis and reality in science. Even the most compelling conjectures ultimately require systematic observation and analysis, and it plays a key role in this. It is a more powerful observation tool than ever. 2,635 meters above sea level in Parkin Mountain, a giant eye was built this year that is quietly changing the way humans gaze at the universe. This is Ura C. Rubin Observatory, formerly known as Large Comprehensive Cyclopedia Telescope, renamed in 2019 in honor of American astronomer Ura Rubin. The core equipment includes 3.20 billion pixels time and space heritage sky camera and the 8.4-meter Simeon telescope with a triple mirror optical system. The mission of this observatory is not just to look up at the stars, but to capture a never-ending rocky documentary of a dynamic universe like never before. The core scientific goal of this cosmic observatory is to capture everything that changes and moves in the sky. This includes tracking 1 million of forbidden asteroids and comets. Building the most perfect solar system ever built is still a census. He will systematically search for distant superstar explosions. The brilliant fire in these stellar forests has allowed astronomers to measure the expansion of the universe. The key to studying dark energy, he can also detect distant starlight suddenly brightened by the attractive force of lensing, and the last signal from a star before it is swallowed by a black hole. The observatory plans to complete a complete scan of the entire southern sky every 3 nights. In planning a 10-year space-time heritage survey mission, he will scan the sky 1,000 times over and over again. A vast universe of more than 20 billion galaxies and 17 billion stars. Dynamic hard equivalent. June 23rd, 2025. The Lubin Observatory has released the first batch of observation images. In just over 10 hours of test observations, the Lubin Observatory has shown unprecedented powerful observation capabilities. He captured millions of galaxies, the millions of stars in the Milky Way galaxy, and the discovery of 2,104 previously undiscovered asteroids in the solar system. This includes 7 forbidden asteroids with the help of the Lubin Observatory. In the future, more interstellar visitors like Zane Atlas may be discovered. The completion of the Lubin Observatory will play the role of discovery engine and chief sentinel in future space exploration. To understand the revolutionary nature of Desai's discoveries, the first step is to understand what dark energy is. In 1929, the American genius scientist Hober first discovered the phenomenon of increasing distances between stars and proposed the theory of cosmic inflation. Afterwards, American astrophysicist Komov proposed the Big Bang theory. He believes that the regression of galactic objects is caused by the impact of the Big Bang. From now on, it's always been assumed that the universe is expanding at a constant rate. Until 1998, two independent observatories studied supernova observation data and found that the universe's expansion is accelerating. This discovery instantly exploded in the scientific community because, according to Newton's law of gravity, the impact of the Big Bang, under the action of attractive force and restraining force, the speed of interstellar bodies' regression should gradually change, even stable equilibrium. However, the findings of these three scientists contradict Newton's law of gravity. There is only one possibility for this phenomenon. That is, there is also a way in the universe that is opposite to the direction of gravity, a mysterious power that is yet to be discovered by humans. It is he who drives the rapid expansion and regression of galactic objects. And that mysterious force is dark energy. He is everywhere but invisible, and yet his influence was overwhelming. Determines the ultimate reputation of the universe. In order to study this mysterious substance in depth, astronomers launched the International Energy Spectrometer Survey, DESI for short. His credible mission is to precisely measure the positions and motions of tens of millions of distant galaxies. By capturing the light emitted by these galaxies as red as the universe expands, DSI can produce three-dimensional maps of the universe across billions of years of cosmic history with extreme accuracy. For a long time, the prevailing view in the scientific community holds that the intensity of dark energy is constant, the so-called cosmological constant. However, the first revolutionary data from the dark energy spectrometer, released in 2025, are shaking up that timeline. The research team analyzed 3 years of observations of 15 million galaxies and quasars by the DESI project, obtained the largest scattered map of the universe ever created, and with the cosmic microwave background radiation, combined data on supernova and weak attractive force lenses to track the effects of dark energy over the past 11 billion years. Ultimately, it concluded that dark energy may not be a constant quantity as conventionally thought. It may decay over time, although this is still an early finding that requires more data validation. But the implications are profound. If it is finally confirmed, will completely rewrite our predictions about the ultimate fate of the universe. He means that the accelerating expansion of the universe may not last forever. Someday, the expansion may even slow down. It's going to start a whole new chapter of what we've known for decades. A black hole is a mysterious object that underlies the extreme physical conditions of the universe. It has been the focus of modern astronomy and physics. In 2025, scientists around the world also made remarkable discoveries in the field of black hole research. An international collaboration team announced they used legal probes to detect the largest black hole collision to date. Since 2015, scientists have observed a total of 300 black hole mergers. The previous record holder for the largest black hole merger event was GW190521. Which was discovered in 2021. The resulting black hole is only 140 times the mass of the Sun. However, in this incident, black holes 140 and 100 times the mass of the Sun, respectively, merged to create a super black hole 225 times the mass of the Sun. This discovery has both excited and puzzled astronomers, because the masses of these two black holes just fall into a theoretical forbidden zone. According to existing theories of stellar evolution, massive stars die. Its core is usually explored as a black hole. But if the star dies with a core mass between 60 and 130 times the mass of the Sun, then the entire star would be completely destroyed in an extremely violent explosion. Nothing is left. A fundamental question ensued. If they cannot be formed from the direct death of a single star, so where did they come from? And the answer is mergers. In the early days of the universe, after the death of the first generation of stars, many smaller black holes formed. They search for each other like snakes in the universe, merged to form a second generation of more massive black holes. This nascent black hole will continue to roam and devour, will combine with other black holes so repeatedly, ultimately became what it is today. This provides crucial clues to solving another of the larger mysteries in astrophysics. Those cosmic behemoths with masses in the millions or even billions by the Sun, the early stages of its growth are likely to be through the merger of such small black holes. Accumulate quality quickly, lay the foundation for the subsequent crazy devouring. Another major breakthrough is also related to black holes. He's an attractive force. Careful friends should have noticed the mass of the new black hole mentioned above is less than the mass of the two black holes before the merger. This is because during the process of black hole mergers, a portion of the mass is released as waves. Out September 14th, 2015, first attractive force signal captured. It came from 1.30 billion light-years away. After the merger of two black holes with a mass of 36 and 29 times that of the Sun, respectively, PowerBuy has ushered in a new upgrade. After the upgrade, his sensitivity has reached 3 times that of 2015. Capture more black hole collisions with greater accuracy. In September, Liga captured another one, about 1.30 billion light-years away. The collision of two black holes, possibly about 32 times the mass of the Sun, produces an attractive force signal. This is the loudest wave of attractive forces ever detected. What about Hawking's prediction? This is a key prediction that physicist Stephen Hawking made half a century ago. It's called the black hole area law. The law states that when two black holes merge, the total area of the world of the new black hole is not less than the sum of the world areas of the original two black hole worlds. In other words, the total area of the world of the black hole will increase with the merger. This attractive force sent us a very clear signal. Scientists can use this to measure the huge changes before and after black hole mergers. The results surprised everyone before the merger. The combined surface area of the two black hole worlds was approximately 240,000 square kilometers. After the merger, the surface area of the new black hole actually soared to 400,000 square kilometers. This means that the universe has completed the signature of Hawking's theory with the loudest sound.